I'm really honored to be here this afternoon, and I hope you all had good lunch. And I know this is not the perfect slot for presentation, but I will try my best to do well on this presentation and give you a glimpse of the clean production research that we have undergoing at the University of New Orleans in Louisiana. Next one, please. That's the title of my presentation. Basically, last 10, 15 years, we have been working on clean technology initiative and using maritime industry as a case study. I want to give some examples of success stories that we had at the University of New Orleans. This slide gives you the basic outline of what I'm going to talk this afternoon. What were our research goals, cleaner production research goals. And as I said, that Gulf Coast is very rich in the shipbuilding maritime activities. Florida, Alabama, Mississippi, Texas, significant number of medium-sized shipyards are present in the Gulf Coast. And fortunately, the University of New Orleans has a nationally recognized School of Naval Architecture and Marine Engineering. Because of this synergy, we were able to contribute considerable research to this area. And also how the student training, that we have a PhD in engineering and applied science master's program, as well as undergraduate degree programs in related fields, environmental and civil engineering, and focusing on sustainability and so on. Basically, the research that we do at the University of New Orleans is directly related to the theme of this conference, the cleaner production, promoting sustainability, energy conservation, material conservation. So my presentation is going to focus on that. Next one, please. So now, within the United States as well as world over, there's a massive effort on promoting sustainability. And if you look at the history, that you have pollution prevention, waste minimization, but now the new buzzword is sustainability, climate change, and life cycle assessment, and so on. But basically, in my opinion, it's the clean production, sustainability, all these things are common sense issues. Basically, be aware of your resources and the limitations of those limitations that you have on these resources, and then the responsibility the community, as a society, the responsibility that we have, and the responsibility to protect the environment. So our clean technology initiative goals were obvious for us. Most of the funding came from the Office of Naval Research and the United States Navy and private shipbuilders. So we were mainly focusing on maritime related processes and materials. And then EPA has a massive effort on this environmentally sensible purchase, or ranking materials that so that upfront. I'll give you a case of shipbuilding, ship recycling. 40 years ago, 50 years ago, the ships that were built using asbestos and then heavy metals and so on. Now, at the end of the ship recycle, at the end of the life of the ship, then you have a major concern regarding exposures to workers as well as the damage to the environment. So material ranking, process ranking was one of our top priority for the maritime industry as part of the Clean Technologies Initiative we had at the University of New Orleans. And also the best process conditions. If you, the first job is to identify the materials that are environmentally friendly, and then the second thing is that understanding the process to the extent that you are able to tweak the process conditions. So you have best conditions in terms of reduced energy consumption, reduced resource consumption, and reduced emissions. Of course, the cost-wise, you want to minimize and then environmental impact as well. So that was another objective. And energy material conservation was another goal of our research. And productivity, improving productivity. If you are able to do the job efficiently, you are automatically addressing some of those pollution-related issues. For example, if you are cleaning a ship's surface before you have to paint, then if you are able to cut down the time by 50%, then the amount of energy used for the same equipment or the labor or other issues. So you are minimizing costs as well as the materials, possibly energy. So increasing the efficiency translates to protecting the environment. So that was another objective of our research goal. And then life cycle costing, life cycle assessment is an integrated part of sustainability, and then cleaner production directly complements these things. So a holistic approach, if you take towards any production cycle, then life cycle assessment, of course, life cycle assessment is a complex process that you have to define boundaries to what extent you want to go, but then having a meaningful boundaries and then evaluating those alternatives from whether it may be a product or it may be a process, that it will lead to meaningful solutions. So that was another. So in order to reach our goals, the first priority for us was to work with our stakeholders, the shipbuilders in the maritime, in the Gulf Coast, as well as with funding agencies and then the regulatory agencies. So establishing collaborations with the stakeholders was one of the important things. And then the second thing is developing infrastructure. So because we were so close to shipbuilding sector, that we were able to collaborate with the local industry, and then we established our resources in such a way that these industrial processes could be simulated on campus at UNO, so our graduate students can perform their experimental runs and then understand the fundamental knowledge required to optimize and then reach the clean technology objectives. Now, this slide shows the collaborations that we had as part of the clean technology initiative within the maritime sector. Of course, the regulatory agencies were very interested in our work, and then the Navy, Office of Naval Research, and then the private yards were very highly interested, because ultimately it helps them, their image, their public PR relations, and so on. And the maritime processes, the four major processes that we worked for significant amount of time these are the ones: dry abrasive blasting, metal welding, metal cutting, and painting. Now today, this afternoon, I'm giving you a case study of dry abrasive blasting, but then the approach is more or less same for all other processes. And within the maritime industry, if you look at air pollutants, particulates is a major concern, and then of course metals and organics. Years back, everybody was concerned about organics, but recently that EPA is looking at hotspots within the United States, that heavy metals are driving some of this risk. And for maritime industry, these heavy metals are the drivers in when you look at the public health risk criteria of 1 in 1 million. And health effects can range widely from cancer to non-cancer, different sicknesses. So the regulatory approach is changing now. Instead of emissions-based approach, now the health criteria-based, and then the EPA is calling this as residual risk assessment. Now, even after reducing the emissions using the current under Clean Air Act guidelines and NESHAPs, National Emission Standards for Hazardous Air Pollutants, now the EPA is coming back to see the risk levels existing for various industry sectors and coming up with new guidelines. Now, this is a sketch of illustration of emissions test facility that was used in understanding the dry abrasive blasting process for the maritime industry. It's basically when you are concerned about air emissions, that you should be able to capture the emissions that are generated from these industrial processes. And if you simultaneously measure the process conditions as well as emissions, then you are able to mathematically relate these outcomes, and then you are in a better position in terms of assisting the production managers and then the shop floor managers to see what conditions will lead to a cleaner production. So this shows a simple emissions test facility and a long duct that draws emissions from the enclosed space. And then you have a that is aided by a blower, and then also we had two-stage air pollution control device so that we do not pollute our campus environment. And also in the picture you see the stack testing equipment that was used. So there are two types of monitoring. One is the process monitoring, other is the emissions monitoring. Of course, the third one is then tracking the materials used or the waste generated. Next one, please. Continue. So this, I have few slides to give you. The time may not allow me to go into various details, but I just want to give you highlights of this research that in dry abrasive blasting. If you see, this is a submarine shell that is being cleaned before it is repainted. So you see when a vessel travels in the marine environment, you have this growth that increases the friction. So increasing the friction means then you have increased fuel consumption, means increased emissions. So every 4 years or 5 years, these vessels have to be brought to dry dock, and then the surface has to be cleaned before you apply paint. So this is called and then there are several ways to clean the surface. But dry abrasive blasting is most common, most predominantly used surface cleaning process within the U.S. shipbuilding sector. So, as I said, the dry abrasive blasting is most popular, very simple process, and very cost-effective. So the private yards, as well as Navy yards, tend to use this process. Not only the dry abrasive blasting is used in shipbuilding, but other sectors like automobile, aircraft manufacturing, oil exploration, offshore platforms, etc. So if you understand the process, then the results and approach can be applied to any other sector. Next one, please. These are some of the pictures that the dry abrasive blasting is used in other industry sectors to remove the old paint or rust or oil and grease, and then give some texture on the surface before you apply the paint. If you don't clean the surface, the paint life will deteriorate. So in order to have a desirable or the manufacturer recommended life for the paint, you need to clean the surface. So this is a picture showing a blast part and then the blaster in a protective suit. So basically the abrasive blasting is a simple process. I'm sure some of you are familiar. You have a pressurized part filled with abrasive. There are 6 or 7 different kinds of abrasives. And then the compressed air is connected to this pressurized part. And similar to a tap, you have a trigger there and a hose. Then when you open the trigger, then the abrasive mixed with pressurized air is shot onto the surface. And then the surface gets cleaned in that process. So this slide shows you basically in this process the two waste streams that are significant are used abrasives that may be contaminated with heavy metals, and then the other thing is atmospheric emissions. Particulates may be contaminated with lead, chromium, zinc, depending on the paint that you use. Next one, please. Now, there are various parameters that influence the productivity, the time of this process, as well as the emissions. So I have listed many parameters that are interconnected, and then some of them are highlighted in yellow. Those are the ones that we track, because obviously in a research you have to go prioritize your areas and then slowly improve upon the results that you have. So initial surface conditions obviously will dictate what speed you can achieve, and then the type of abrasive that you use. As I said, there are different abrasives used in the industry like coal slag, copper slag, garnet, steel grit, and specialty sand kinds of things. So each of them have different efficiencies associated with that, and then also emission potentials. And then other significant parameters are blast pressure, abrasive feed rate. These are and the grade of the abrasive. By changing these process parameters, we observed that the speed at which you complete the job, and then the consumption of abrasive materials for cleaning certain unit amount of area, and then the emissions. So we tracked those very closely and tried to find mathematical relationship between these process parameters and emissions. Next one, please. So the focus was on productivity, which is defined as the area cleaned per unit amount of time, maybe meter square per hour, and then consumption is amount of abrasive used for cleaning certain unit area. So kilograms maybe per square meter. Of course, you have this FPS system. US still uses FPS system, but I know that Brazil uses SI system. So now, then the next thing is emission factors. That EPA was highly interested in knowing the amount of pollution generated, the particulates generated per unit amount of area cleaned. So the kilograms or grams per square foot or square meter cleaned. So these were the things that were tracked in the research. Next one, please. So the study that we did in this case, abrasives, we looked at 6 abrasives: bar shot, coal slag, copper slag, garnet, specialty sand, and steel grit, based on a survey of the United States shipbuilding sector. These were the predominantly used abrasives within the US. And then also we surveyed, based on that, the blast pressures was used between 80 and 120 PSI. Then the feed rate, initial, those are the ones that I listed. I see that there's a time sign, so I had to rush. Next one, please. So this is a matrix showing that how the independent and dependent parameters were designed in the design of experiment. So next one, please. So this is a photograph showing the emissions test facility. Some of them are pictures that I just wanted to give you. Next one. So the results, now productivity increases with blast pressure. In many cases that we found those relationships. These are the important outcomes that will aid in clean production in shipbuilding industry. So the goal is obviously you want to maximize productivity, reduce consumption, reduce PM emissions. Then you would satisfy your clean production goals. Next one, please. Now these are some examples of the results, but then so if you mathematically can relate these independent and dependent parameters, you have a solution. For some cases you need high point, for some cases you want low point. For emissions you want a low point, for costs you want a low point. For for productivity you want a high point in these curves. Next one, please. Next one also. So now this research has helped us rank these 6 materials. How do they perform with respect to their environmental performance? And we were able to generate models connecting the total PM emissions based on process conditions. And then we were also able to generate, develop for productivity and consumption. So now all these models were helpful in writing a computer code to find out, optimize the production process, reduce costs, reduce consumption, increase productivity. So, but then in order to write a computer code, we needed a model that connects all these conditions. So that was achieved in the phase 1. And the phase 2, I have few pictures I just want to quickly show you. So now, how this clean technology initiative being utilized in the industry. So then that basically helps in life cycle cost reduction, life cycle environmental impact minimization, and compliance through UNO's the computer code that we generated basically ranks various process materials and can predict what would be your emissions next year if you were to use certain materials and certain conditions. And then also protecting worker health, because once you rank certain material to be higher with respect to risk or environmental performance, you can utilize in a meaningful way to promote cleaner production. And then also public health risk reduction. Next one, please. Now these are, I'm not going to go into the details, but this is a summary slide of life cycle costing and assessment for applied for dry abrasive blasting. Next one. This is an expert environmental management system for environmental complaints. All the knowledge that is gained through ground level was incorporated into this. This not only has abrasive blasting, but many other processes used in shipbuilding sector. Next one. And also now this model, the software application is incorporates the health risk criteria, because EPA is going towards health risk criteria rather than emission limits. Next one. And then these two slides are very basic, that carcinogenic, non-carcinogenic cases. How do you take this emissions information and then find out the carcinogenicity and non-carcinogenicity among the individuals, and then how you will be able to incorporate into the models. Next one, please. Next. Okay, this is again a flow diagram, how we were able to use the information into developing the models and then health risk criteria. Next. This is another summary slide for protecting worker health. The previous slide was for public health, and then this is for worker health protection. Next one. This is again, it is a very complex but then very useful software application. Uses the knowledge that we gained through cleaner production research. Now, current and future studies, additional work on abrasive blasting. So far, we were able to look at the particulate emissions and understand the process. But the next step is understanding the heavy metals contained, and then if you change the paint, what will happen to your emissions, and what does that mean to risk. So this abrasive blasting appears to be such a simple process. There are so many things that we don't know yet. So there's a lot of work ahead of us. And then the other area is metal welding, that because of the its potential to emit hazardous air pollutants, heavy metals, that's under focus. And then we are looking at landfill emissions to estimate methane, CO2, and hydrogen sulfide. You have heard of Hurricane Katrina and its damage to New Orleans. We generated a lot of waste, and then that is causing hydrogen sulfide because gypsum board has calcium sulfate that generates hydrogen sulfate. So we are working on that, and remote sensing techniques to monitor air quality and then provide feedback to cleaner production. So far we focused on maritime industry, but the concept is applicable to any other industry sector. So that's what I wanted to demonstrate. And students are trained at UNO, continue to promote CP. The last slide now. Well, I know it's a very short time to cover the years of research, but I just wanted to give you a glimpse of what is going on at the University of New Orleans. We invite collaboration with other researchers around the world, and then I'll be happy to talk to you, and then I'll be here all 3 days exchange. But that's a quick summary. I'm sorry I had to rush, but I just wanted to at least generate interest so that we can have a dialogue at coffee time and so on. That's all. Thank you.